Welcome back. Thank you for clicking on today's video. Today we're going to be doing a confidence interval for two independent population means. So this is still the same with all the FRED, so nothing really changes for these two from what we did for the hypothesis test. This executing calculations will be a little different because when we calculate this, we're calculating a confidence interval, not a test statistic. So the formula for calculating a confidence interval is going to be x bar sub 1 minus x bar sub 2, and then you'll multiply that by the standard error formula we're using for this data, and that's going to be s sub 1 squared over n sub 1 and s sub 2 squared over n sub 2. So when we draw the conclusions, we'll do that the same way we've done with the other confidence intervals. You need your confidence level, your parameter, and this time it will be parameters, plural, and the confidence interval itself. So those are the basics of the FRED, and I'm spending less time on it because we've already done a confidence interval and we've already done a hypothesis test for this type of data. So we are going to be looking to see what the difference between watermelon weights are for a garden versus grocery store. So I have my sample estimates for each of the two groups. One thing though, when I started collecting this data, at first I thought that grocery store would make sense to be group 1, but now because of the difference in the sample means, I want grocery store to be group 2 because I want an interval that's positive. It makes it easier to interpret, and because I'm doing this confidence interval, I get to choose the order. So sometimes I choose the order for you. Sometimes you'll have to choose it yourself, but that's one logical way to think about it, is you kind of want the larger sample mean to go in first so that you're interpreting a positive interval. Okay, so we're going to start with the F, and here we would have two populations. Population 1 would be garden melons, and it's actually garden watermelons. And then population 2 would be grocery store watermelons. And then the sample 1 would be 38 garden melons, and sample 2 would be 35 grocery store watermelons. Okay? Then our variable is going to be their weight. And remember, for these, you'll have two separate parameters. So here it would be mean weight of garden melons, and then mu2 would be mean weight of grocery store melons. So that's the F in our FRED. The next thing that we're doing then would be R. And for reviewing conditions, remember you need it to be independent. And we know that the melon weight for grocery store wouldn't impact the melon weight for garden melons, so they are independent. I don't have the histograms and box plots, but those are both symmetric and there are no outliers. So we've reviewed those conditions and can move on to executing our calculations. So now to set up our calculation, we have x bar sub 1, and you know what? I'm just going to write them out. Those out of my way. 15.84, and then we're subtracting 14.56. Technically, that's our point estimate. So that gives me 1.28. Then we need my t star so I can find my standard error. So for this, I'm going to use conservative degrees of freedom, and we talked about that in previous videos, but that means you take the smaller n and subtract 1. So I'd be between 30 and 40, and I want a 90% confidence interval, or excuse me, 95. So my multiplier would be 2.04. So 95, and we're going to use the 30 degree of freedom row because we're in between. So actually, if for either of those, that would be the multiplier, but always go down numerically. So, whoops, daisies, that was 2.04. So that is my t star, and then we are going to do the standard error, and then we'll multiply those together to get our margin of error. So here we have 2.74 squared over 38 plus 2.27 squared over 35. So I'm going to plug that all into my calculator. So I have the square root and then 2.74 squared divided by 38 plus 2.27 squared divided by 35. And here's my standard error. So about 0.59. And I'm just going to leave it in my calculator. And my margin of error, then remember, are these two multiplied together. And here we get 1 point, and let's round correctly and get 1.20. So that's what we add and subtract. So these two things created this. Now this is going to be added and subtracted too. So we have 1.28 plus or minus 1.20. So here that would give me a lower bound of 0.08 and an upper bound of 2.48. So really minimal difference, but 0 is not included, which means there is in fact a difference between the average weights of grocery store and garden watermelons because 0 is not included in that confidence interval. So now when we go to interpret this, we're going to start by saying how confident we are. So here we are 95% confident. And then what I'm going to do is I'm going to take my two parameters. So I'm going to start with mean weight of garden melons. So we're 95% confident the mean weight of garden melons is between, and now I'm going to state my interval, which we just had was 0.08 and 2.48 pounds more. And I'm saying more because the interval is positive. So if the interval was negative, you would switch the negatives to a positive, but then say less. So we're saying more because it's positive. And then I'm stating my second parameter. So that's mean weight of grocery store melons. And that's it. So if you have any questions, let me know. Otherwise, that's how you do it by hand with the Fred method. Pretty easy to translate this into using our output. See you in future videos.